Okay, let's, unless anyone tells me otherwise, let's get going because we don't want to wait for too long. We've got quite a busy, action-packed schedule for this session this morning. So allow me to welcome you all to the research data architectures in, I'm forgetting the name of the group now. So the research data architectures for research institutions. It's a little bit of a mouthful of an interest group, but we have been going now for quite a few sessions of our diary. We've covered a broad range of topics in that time. Today we're going to be looking at, bring up my notes, some experimental systems and things that people have been trying out for preparing data for interchange and openness. So in this group, we look at things from a bit of an institutional perspective in terms of what can institutional managers pick up and run. So hopefully we'll hear some great ideas of things that people have been trying out and using to help people share data and reuse data elsewhere as well. And they'll be looking from a technical side of things as well as an organizational side of things and a bit more of a kind of a social side of things as well, I think. So welcome to the session. My name's James Wilson. I'm one of the two co-chairs. We also have Keith, who can presumably see nearby, who's Keith Russell, who's another one of the co-chairs. And we'll be putting out a plea for more co-chairs at the end because there's just the two of us at the moment and we could always do with a bit more support. Basically, what we're going to do, we've got 5 speakers today, so we will go through each in turn. It's a fairly strict 10 minutes for each of the speakers because we do have quite a full agenda. After each of the speakers has said their bit, I think what we'll then do is a general Q&A session for everyone here together. If you want to put questions in that we will come back to when it comes to Q&A time, please do put them in the Q&A tab. So you should be able to see to the right-hand side of your screen that you have a chat tab, Q&A one, polls, and if you're me, you get to see the moderators one as well. So use the Q&A ones for formal questions you would like us to deliver at the end of this. Use the chat if you just want to comment on things. And of course, feel free to use those emoticon fountains that we have at the bottom of the screen whenever you want to express your appreciation or shock for anything that anybody's saying. I think that covers most of it. So without further ado, let's get going. And we'll start off with Daniel Moore talking about continuous integration for research data, experiments with adapting concepts from software development to research data management, an in-house repository. Daniel, take it away.
Yeah, hi, all together. Oh, where are my slides? You see my slides? Ah, okay, I also see my slides. So continuous integration. The problem for us was we need an in-house data repository. And now at the moment we are trying to test something. We'll quick go through the table of contents. First of all, I will give an overview to just present you where we have the problems, let's say. And then I will go to the planned environment. And then in detail, I want to talk about the access ports and the utilization, and there also the continuous integration part. As an introduction, let me repeat, your data is nothing more than a data bubble until it is described, shared, and published. But this is not often done. The typical steps are only created, or the data are created, e.g. measurement in the lab or somewhere else. After this, an analyzing step is done. The people are using scripts or programs to analyze the data. And maybe they try to share the data to co-workers, but in practice, they send around the data by email or exchange by USB stick and so on. Then they create derivative work, or they create directly a publication, e.g. a paper. And then the publication is published somehow, but only the publication is somehow archived. So the data itself mostly are lost. The idea is for us, or the perfect world would be, the data is created. After this, the second step is store the data in a good way. In a good way, I mean here something like data integrity, data security, version control, and also should be possible to access by co-workers so that the data are not duplicated or sent around by email or whatever. And also there should be access for tools to analyze the data. And this should be at least simple for the tools. So it doesn't help if the tools have to understand complicated protocols or something like this. Yeah, next step, analyzing data is the same. Creative work is the same. Maybe all this is done also in the data storage. The preparation of the publication, create the publication, and then the next good step should be archive the data, the analyzed data, and the publication. And maybe also after this, a reuse of the data should be possible. We are here at point 2, store the data in a good way. There we need a solution for our DLR institute. So the idea is we would have a centralized server instance. This should be easy to cooperate between the people who want to access the data. And the server should keep the data integrity. This is on the server done in a professional way and not on a USB stick. Therefore, this is a good idea, I think. At the back end, we use a JIT repository, so we want to use JIT repositories. This is a common tool, and it has options for continuous integration. I will come to this later on. Advanced stage of development is already achieved for JIT, so it should be stable at least. Decentralized use is possible. For large data, JIT is not the right way, but JIT Annex is a possible extension to use this. Further, we want a common access, SSH, HTTPS, and to get the data in an easy way for scripts, etc., we want to use DAF-S. Check use the metadata by continuous integration could be done by JIT-Hoop, for example, and there we are thinking about JSON and JSON scheme. I think this is sustainable technologies and tools, so it's good to stay on these stuff, I think. Let's again look a little bit deeper. The server. The server has the access points, SSH, HTTPS, and DAF-S. So those are typical access ports. And JIT, you can use it on nearly every system. There's a client available. There are also GUIs available. Has read-write access, and it uses to the server the access ports HTTPS and SSH. You do commit messages when you put in some data. This means metadata of changes is somehow stored, and the user become a kind of awareness of tracking. So the user knows that he make a commit step and has to put it in. WebDAV or over DAF-S, a secure secure protocol should only get read-only access, so no commit messages, no write access, only read-only. The user can mount the content. The content is available for scripts in a file system or in the file system of their system. And also here, GUIs are available. You can also access the web stuff typically by a browser or something others. The server then should give a possibility of cooperated access. So everyone can access the server, but not the user have to access the computer of the other user or some other complicated stuff. It's centralized. And on the server, we could manage professional storage. The JIT backend on the server gives the history of the changes and allows automatic processes. I will come to this. And then the next step is the extension JIT Annex. This uses the typical protocols which are also used by JIT, which means HTTPS or SSH. Here, large files are possible, or it is especially a tool for large files, we should say. But also possible with JIT Annex only to upload reference data. So not directly the file itself, but a kind of link to the data where it is stored. So if you have a special archive on a compute server and the data is managed there, then you can also reference this here. Yeah, important for data larger. JIT Annex is especially important if the data are larger than the available memory, because JIT uses a compression stream, and typically the data would be completely in the memory of the computer. So JIT is only for, more or less only for small data or for the metadata, I would say. Let's have a quick look at the example use case. A user could upload the data to a repository. Let's say here a data management plan, for example, a controller, a human people, or also automatic system can access this and scan it and store it into storage, or decide to put the data to the metadata web server for a publication or for a later publication. But there also it gives a feedback to the user, and or the controller already gives a feedback to the user. Is the data management plan okay or not? And then we have an iteration, and until the data management plan could be okay, or the metadata could be okay. So little bit more detail. Let's have a typical repository. I think there should be a JSON instance and a scheme to describe this. Let's say data bubble for DABU JSON or DABU scheme, or data management plan if you come more familiar with this, more complicated stuff. So data bubble here or DABU just means small, simple, only for the beginning. It's not for the end, it's not for the publication, it's just to hold the first stuff of metadata of the data already there. Then the data itself, then there should be also a license, then you know how you can access other people, or you can share it, and also README to describe it for a human. Yeah. And here the automatic build processes can help. So JIT from programming routines, let's say, have continuous integration inside, and there we can validate the JSON document with the JSON scheme, and after this inform the user or also a supervisor by email if not okay. And there are two possibilities then. The user can enhance this JSON instance, or the supervisor can give the JSON scheme to describe for the user what you want. And the supervisor is not only the person directly the supervisor of the user, it could also be a centralized instance in an institution, e.g. in our case DLR. There could be a JSON scheme for the complete DLR, for example. And other possibility also is there, then the commit is rejected and the user has to done something. Further, we could, with this continuous integration, capture metadata from this JSON instance and put it in a search index to share the data or to make it findable. Also, just further metadata based on provided data files, or other things, suggest further metadata based on commit messages, because the commit messages are also something what is tracked here. And I think this is altogether a good idea. And, but it's only for prepare and collect metadata for publication in an early step. It's not for really the publication itself. But we could, with this tool, let's say, prepare for a final publication, I hope. Thank you.
Perfectly to time. Let me just see if I can get that back, and we can go back to the main screen. Thanks, Daniel. So what we're going to do is we're going to wait till the end of the session, I think, before we go through the Q&A. Questions for Daniel, do add it to the Q&A tab on the thing. Also, be aware that we have a collaborative note-taking system that we're using for this. So we have a Google Doc, which we're all collaboratively editing to take notes about what people are covering, what they're saying, and the suggestions they're coming up with. So if you would like to join in the editing of that and keep a good record of what we cover in this session, please do so. I think, with any luck, my lovely assistant Keith will put the link back into the chat. So I think it's in there now. So without further ado, let me bring my agenda up again. And we will welcome our next speaker. I think we have Fenella France, who will be speaking to us about reining in cultural heritage data APIs for better accessibility. Fenella, Andrew, are either of you there? I don't know who's going to be presenting.
I'm afraid Fenella can't be with us this morning,
Okay.
so I'm going to struggle on through, if that's all right.
Okay, brilliant. Thanks, Andrew.
Thanks. It says it's showing my desktop, but is that visible? Cool. Thank you. Normally, my division chief, Fenella, would go through some background information about the kind of research we do. I might just, in the interest of time, skip through that. But at the Library of Congress, our Preservation Research and Testing Division gathers data from scientific research, but also large quantities of more humanities and museological data too. And some of these are ongoing projects with monitoring, for instance, but others are very preservation specific to an object or a research query from elsewhere within the library or one of our
very quickly
partners.
we can see your desktop but not any slides. So if you've got slides up, it's not the screen you're sharing. You might just want to press a few buttons and see if you can get the slides up.
I'm literally selecting the stupid slide, and
we should, I think, have some technical support on the line, because I'm sure you're not going to be the only one with a few slide issues.
Hi, Andrew.
Yeah.
What web browser are you using? This is Hannah from Juno.
This is Firefox.
All right, so if you just put your presentation in front of this window and you are doing your whole there, we can see that now.
You can see that right now?
Yeah, so if you go into presentation view now, we should be able to see that.
Yeah. Very odd. Okay. Is that, yep, right. Sorry about that. I'm sure I tested this before, but anyway, moving on. Thank you. Lots of often quite messy data related to times or objects or
Andrew, I'm sorry, are you in presentation mode?
I am in presentation mode.
Okay, it looks like we're seeing notes. Can everybody else see the full presentation, or are you still seeing notes?
I can see 10 different slides, but they're each far too small to read. So I think
is this going to work?
Zoom in. Right. That's got it. There we are.
Okay, this is weird. So it doesn't like full screen mode, just a heads up to the next people. Okay. Lots of quite messy data. We've had a number of prototypes over the last few years to try to rein this all in and present data visualizations for conservators, but also humanities researchers. And these worked really quite well. Often, well, no, I have been building mostly in Rust, REST APIs that handle the backend work, and other databases like Couch that I can access via REST as well, just to pull things up and do all the actual thinking, working logic in a front-end app, like using something like React. And the reason for this is that things change all the time, and I would go completely insane if I had to manage back-end and front-end all the time, updating along with my actual day job. One of the obvious advantages with REST is that, and microservices generally, is that you have a nice isolated one task, do it well application, and you can set it up and leave it alone and not have to think about it unless things change, which is my life. In which case you start to get old code and access methods lingering around, and some prototype somewhere depends on it, so you don't touch that and it all just swells. One of the major projects that I'm working on at the moment is to try to gather all of our research data and link it appropriately with research partners, but also the wider Library of Congress infrastructure, the work that the conservators have been doing, as well as the work that the curators do, and this could be worked out with more REST APIs and microservices, except I just know that this is going to expand and change over time, especially in terms of the export formats. With linked art in particular is a work in progress itself. So I'm expecting change. When Keith and James were talking about this session, one of the first things I thought of was GraphQL and Relay, which I was looking into to use to manage sort of the interface between the backend and the different types of access to that data that I could reasonably expect. And nobody seemed to have heard of either of these, so I thought I'd give a brief run through of it. In short, it is a means to establish a schema on a server that is typed so that you can make queries against all of your different backend services, including third-party ones, organize it in one schema, and then just run your queries from the front end against it. There are lots and lots of additions to it. It's been adopted on a large scale by GitHub, but others like Netflix and Facebook use it internally, all way beyond the scale that we're anticipating in terms of traffic. But the idea of a typed interface appealed a great deal to me. There are some caveats. While a lot of it is highly optimized for web traffic, some of the weird little edge cases are that Relay, for instance, for pagination, it prefers you to use an infinite scrolling thing, so you're always loading more and more and more, which is not great for research data. But it's not, I mean, I can share, if anyone is interested, the ways that I've worked around that. It's not a showstopper at all. But what I wanted to show here is that you can model your domains in a way that makes sense, not for your databases and microservices and all that other jazz, but for the users that are going to be accessing it. Secondly, Relay itself allows for front-end developers to compose how that data, once pulled gets distributed within your applications. So here's an example query that would be gathering the pressure, relative humidity, and temperature from some sensor readings for an enclosure between this period, 2010 to 2020, along with any service notes that might occur on those sensors in that period. And so you have this query, and we're asking for an enclosure. Which enclosure? Well, we want the Volts-Müller map, and we want our location. I want sensor data between 2010 and 2020. Give me the ID, the location. I need the notes as well, please, along with when these notes were created. And I also want the measurements. There may be in your schema many other data points that you could query. In this case, that is all I care about, and that is all I expect to see get back again. I am running out of time. A typical response to this query would look like this. It's just straight JSON. You can have it spit out whatever you want, but again, if you're using, say, the Relay client, and personally, JSON is lovely, so I just would work with that and not do anything too fancy, except perhaps JSON LD. Anyway, here it tells me the location. It gives me an array of sensors. In this case, I've just given one, and I get my sensor ID, I get the location, any notes in another array, if they exist. If they don't, it's just an empty array, and then all my measurements. One thing to note here is that with fragments, if I wanted, my query could defer this measurement information to a child component, say a table or a data visualization plot. And that is essentially it. Sorry, I just saw 10 minutes come up. Yeah, there is a lot more to it, lots of extras and fun things, including optimizations for batch loading, caching, reconciling local stores with the server, merging all that, authentication, lots of fun stuff. Yeah, highly recommend at least looking into the system. And
brilliant. Thanks very much, Andrew. I was actually going to give you another couple of minutes there, given the initial problem with the slides, but thank you very much for the presentation. So another reminder, do please put any questions you have about things you can do with some of these technologies, ways they could be applied, anything like that you're interested in, do add them to the Q&A, and we'll come back to them after we've heard from our speakers. So the next speaker I know is here because she's already introduced herself to me. So Magdalena Saira, comprehensible data sets, how an ELN infrastructure can support researchers. So we had a whole session on the ELNs last time round for the Ardari group, but we've got a bit more for you now. So Magdalena, take it away.
Thank you. I hope, one moment. So I hope you can see my presentation now. Yes, very good. So yes, thank you for the nice introduction. My name is Magdalena Saira, and it's a great pleasure for me to be here today. And I will talk about ELNs and how the software tools can support researchers. Just a short overview about my talk today. I will shortly introduce the state initiative FDM NRW, where I'm working, and the Eln Working Group, and then I will talk about some basic properties of electronic lab notebooks and how they can support researchers. And in the end, I will talk about some common difficulties and challenges that one can encounter when implementing an ELN environment. So yeah, briefly on the background of my work, I work in the state initiative FDM NRW, which is funded by the Ministry of Culture and Science in NRW. And here in NRW, we have a very high number of higher education institutions, namely 42. And therefore, we have a heterogeneity in the scientific landscape, as well as the state of institutional services. Nevertheless, there's always an opportunity to cooperate at one point or another and to identify synergies. And our task in the state initiative is to be the central point of contact for infrastructure stuff when it comes to RDM topics like ELNs. So we monitor national and international activities and build and maintain networks, develop training opportunities, and initiate cooperations between universities, especially in the area of infrastructure. And therefore, my talk will be less technical, but rather on another level. So about the ELN Working Group, this is one possibility to network and exchange. And the ELN Working Group was founded in April 2019 with the aim to promote the topic of ELN in North Rhine-Westphalia. Before the pandemic, we met at different universities, but for the past year, our meetings, which are attended by between 20 and 100 people, have been held digitally. The community that comes together here actively deals with the topic and supports each other. We share experience from different perspectives, from infrastructure as well as from researchers. We discuss framework conditions and test software tools. Since last autumn, a sub-working group has also been formed to deal exclusively with technical aspects of implementing and developing ELNs. And here it was possible to agree on an open source software that is in the focus of the exchange in most cases. Since not everyone present today, I guess, has a natural science background, I will briefly summarize basic points about lab notebooks. So any kind of research is based on good planning and documentation, and you will have to know what you did in the lab, not only yesterday, but like 5 years from now. But also to enable other people to understand experiments and results. And furthermore, there's the good scientific practice, which states that lab data must be documented and archived for at least 10 years. So since time began, people have been writing in lab notebooks, a kind of diary in which the research process is documented. Besides data, connections are made between different experiments, instructions are described and deviations from these instructions. You take hypotheses there and reject them again, and all this is supplemented by drawings, pictures, and graphic analysis, and so on. But handwritten works and analog books also have a number of disadvantages that we can work around these days. So sometimes handwriting can't be readable for other people or for yourself. Lab books and experiments can be separated, as the book always have to stay in the lab. So if you move to another institute or country, you have to leave the book there. Yes, books can easily get broken either by fire, water, or they can get stolen. And last but not least, we live in a digital world, and almost 90% of the data in the life science is digital, but are stored in an analog form. So this anachronism, ensures that a lot of data can get lost or is not linked in one place or not easily accessible for other people. So one solutions are electronic lab notebooks, short ELN. And these are special software tools to document experiments in a comprehensible way and to simplify the work in the lab. All large ELNs are web applications where the researcher just can log in and access his experiment. The market of these ELN tools is very large and very heterogeneous. You can find either generic ELNs or discipline-specific ELNs. Furthermore, there are proprietary solutions as well as open source tools And each of this has advantages and disadvantages. The functions are, of course, everything that an analog lab notebook can do. Plus, for example, you can directly link experiments and shared resources like databases. They are searchable. You can search for keywords, whole text or data. You can trace changes. You can use and share standard operating procedures. You can easily attach multimedia like videos or audios, and you can directly comment and discuss with other people. And in terms of research data management, data deposited in an electronic lab notebook can easily be made fair. So now about comprehensible data sets and how ELN can support the researcher. So the ELN, the use of the ELN per se already includes a number of possibilities to make data open and traceable. With the help of these two screenshots here, I will show you what you can see. I think it's a little bit small maybe, but I hope you can get an idea. So this is screenshots from the open source software ELAB FTW, which is very common. And yes, for example, here you can see that dates and times of the processing steps are automatically recorded. You can assign tags that allow experiments on the same topics to be directly grouped together. Furthermore, it is easy to share and collaborate the data or groups of data sets, either directly in a software or in a, as a PDF. You can use comprehensible lists of the procedures. You can add, as I said, directly multimedia. Yeah, furthermore, you can integrate the database where you have specific chemicals and cell lines, and you can add informations like the LOT number or the opening date and so on. And furthermore, it is easy to attach previous experiments or related literature to the experiments. Furthermore, each and every experiment receives a unique ID, so it is always clear to which experiment you refer. So in summary, the use of an ELN alone captures more extensive data, as well as metadata that would probably not be recorded by hand. And in addition, resources, hypotheses, results, and data are more easily kept together in one place. So that was like the researcher's view of an ELN, but how can the infrastructure still support? So ELN should be embedded in an overarching RDM concept so that data can be easily pushed into a repository linked to the curation or addition of metadata. The automatic ingestion of metadata without the scientist engaging is an intermediate level to the smart lab vision. In the smart lab, everything in a lab is connected to each other, in which all hardware and software are interconnected, so just the data can flow automatically and converge in one place. Furthermore, it is important that the researcher are sensitized to the topic of FDM, fair and open data, through an ELN, and they can be easily supported, for example, by data stewards or in curating the data. By committing to subject or institution-specific specifications, it can be ensured that metadata sets are appropriate and comparable. And by encouraging researchers to publish in data journals and supporting them along the way, the importance of comprehensible data sets becomes even clearer. So together, the documentation becomes more comprehensive and at the same time less time-consuming through the use of a well-integrated ELN. So I will come to the end of the talk. There are still a number of points that need to be worked on. First of all, as I already mentioned, the market of ELNs is very large and heterogeneous, so the choice of the right ELN is important. There's no one-size-fits-all ELN, and it may be necessary to offer 2 or 3 tools at the same location in order to meet the different needs of the researchers. An ELN alone only covers, talking about the life cycle of research data management, only one part of this research data life cycle. So it has to be integrated into a suitable environment where data deposition in a repository is possible, as well as data storage and archiving. On a technical level, the development of interfaces is still in its beginning, so that the automatic transfer of data and metadata and the exchange between different ELNs is not always possible today, but hopefully in the future. So in summary, ELNs are an intuitive tool that can help researchers make data more understandable and are therefore well worth investing in. So I thank you for your attention, and I will be happy to answer some questions later. And if you have questions later on your mind, please do not hesitate to contact me later on. Thank you.
Brilliant. Thank you very much, Magdalena. Very good overview, I think, there of ELNs, and I'm sure there'll be questions. I can see questions coming up already for that one. Do remember to put any well-phrased questions that you've got into the Q&A section, and please do ask some questions of our speakers so far as well. Let's move on. Where's my agenda? So next up, we have Holger Angenant. I'm not sure if I'm pronounced that correctly. Apologies, and do correct me if I'm wrong. Talking about democratizing verification, handling collection level tools to coalface researchers.
Yeah, thank you, James. Let me just share my slides. And you should now see my slides in full screen. Is it true? I'm sorry, I cannot hear you anymore. Okay, please interrupt me if you can not see my slides.
We were able to see it before.
Okay.
That's it, we've got it.
Okay, great. Sorry. Yeah, thank you for giving me the opportunity to speak here. Let me waste 2 minutes on who I am and why I'm talking here. So I am currently representing Guido Eben, who is at the moment sharing another session. So he asked me to jump in for him. And since we are working on the same project, the CS3 Mesh for EOS project, he asked me for a topic that I'm in. And I'm now talking about the Skibo Research Data Services, in short Skibo RDS, and these are now developed under the umbrella of the CS3 Mesh for EOS project. This is a CERN-led EU-funded project about collaboration and data management, and we from the University of Münster and Duisburg-Essen are building one of the components, the mentioned research data services. The idea here is that most users nowadays are already using some kind of sync and share services, like Dropbox for universities. So we are offering an own cloud for a couple of German universities, all of them in North Rhine-Westphalia to be exact. And there are already some other services for research data, like Zenodos for publication or archiving services offered by your institution. And we think that the problem here is that the researchers need to visit all those services one after another, and have to enter metadata every time they want to use those services. And we are now trying to build a single entry point in the sync and share service, like own cloud, to make it possible to enrich your research data with metadata by an integrated interface and push them from there directly to the services you want. And this is not only done for us, but we developed this as open source so that any other administrator, researcher, you have to be an administrator of your site, would be able to make use of our work here. More on this later. But first, some words on how we try to make this user-friendly. there was a co-work with the University of Duisburg-Essen and the Department of Information Science there, and they are doing some interviews with users, different researchers, and trying to find out what is their current workflow, what would they want their workflow to be, so that we can make a very streamlined interface and to make it easily accessible for the users. Since I am more the technical guy here, and my key role is being the administrator of Skibo, our own cloud, I'm not very deeply into this topic, but let me just focus on we are trying to give benefits to all groups for the users in creating a good interface that is intuitively to use, for the administrators that want to make use of Skibo RDS to make it easily configurable and get an immediate overview of what you have there, and also for developers that want to participate at the project, because we are not a closed user group, but we are open for collaboration. And we are doing everything with those standard tools like GitHub, GitLab. We have a CI/CD infrastructure, and with the help of this, we are doing an open documentation on what we are doing and how to use this. The workflow, as it should be for the users, is that you put your data in your own cloud or Nextcloud, or in future also C-file. You create there your project, put in then the files to your project, and in the next step, then you can use an editor that is currently being integrated. This will be Describo, a tool developed in Australia, and currently a web integration of Describo is built that will be integrated into the service, so into Skibo RDS. And with the help of this, you can put so-called RO crates inside of the directory where your research data lives, so that you have a sidecar with your metadata. And this can be then pushed to the services that you want to use. This can be at the moment Zenodo and the Open Science Framework, but there are more to come. Our workflow in developing the project is more like we searched for requirements and make analysis, as I already stated. Then we developed a functional prototype, had interviews with the users, created then a mock-up and click dummies of the interface as it could be, made then a study with this, and now are trying to implement what was the outcome of those studies. It says here new user interface because one of our main work is creating interfaces for multiple sync and share services, and the new interface here is meaning the new own cloud interface, because they are just moving from one interface to another. We also are playing a bit around with digital nudging, but that is more a side note here, so let's skip this for the moment. Now we'll get a slight overview about the technical background of the project. I think this is the most important slide here, so I will try to explain how it is working technically, what we are doing. Skibo RDS is let's say kind of middleware. So a piece of software living in between your sync and share service as it is. This green elephant here stands for Skibo, our service. This could be an unbranded own cloud or Nextcloud, you name it. On the other side, there are multiple services you can imagine to be connected here. as I already stated, the Northern OSF. We have in Münster here an archiving service that will be connected. We are aiming at connecting Invenio RDM, also run by CERN, at least developed by CERN, and the Riva service. This is the core component of the earlier mentioned CS3 Mesh for EOS project, so that Skibo RDS will in this way be part of the project. And this focuses on connecting different sync and share services. It's not the most important part here. My point is Skibo is not a part of these products here, but lives in between, so that the need for modification is as small as necessary. So no modification needed on the right side and almost none on the left side here. A small app is needed that we are developing too. You can see this in this slide here. We are developing rather small cloud apps and the RDS core, which summarizes multiple ports and services connecting the outside services. So the main difference to a more naive approach that could be developing an OwnCloud ad, for example, to connect OwnCloud with the services on the right-hand side here is that we do not need to create a single app for every connector, but only a connector to Skibo RDS. And the OwnCloud and Nextcloud app will be rather similar and not that complex. And on the other side, no work is done if you change something on the left side here. If you want to participate in the development, then you can do this because the code is lying on GitHub, and from there it is pushed to our GitLab. The documentation is created automatically, and there are container files runnable in Docker or Podman created, and these then will be running in a Kubernetes environment for us, or in other environments. This could also be, if you do not have a big Kubernetes cluster, only a simple Minikube environment. So to conclude my talk, we are not only aiming at connecting our researchers' services with our sync and share service, and therefore developing the single entry point, but also looking for project partners and participants who are willing to join us in the project or only use what we are doing. And yes, please ask us any questions if you are interested in this. Thank you for your attention.
Brilliant. Thank you, Holger. A very good talk. I've noticed when people answer questions in the Q&A, it does seem to come up with a rather large green blob over the slides. I don't know if anyone else has found this, but it might be a good idea if we hold off on that until the final presentation is done, just so it doesn't get too distracting. But I will then go through the top voted questions, and also I'll open up the floor a bit. So if people just come up with a question or a follow-on thing from anything that we said, we can start to get a bit more of a conversation going as well. Let's move on to our final of our 5 talks before we go into the conversation mode. I'd like to welcome Lars Velhuber, who will be talking about improving reproducibility in the social sciences, some of the challenges that we're facing. Lars, over to you.
Okay. Is that the right one? No, that wasn't the right one. Can you see those slides now? Okay, can't see myself, but that's fine. So I'm going to have a institutional view, as James originally mentioned, of.
Yeah, sorry, Lars. I realise now that what you're showing is not the slides. It's I think it's actually the collaborative notes. So I don't know if you can move on to another one of those screens. New technology, it's new to me anyway. It's bound to cause a bit of confusion.
Yep, we'll try. Let me actually make this simpler. I'm going to detach this tab, and then it'll be hopefully obvious what I'm sharing. Nope, this is screwy. Okay. I'm just going to go with this. So now you should be seeing the whole screen, and now you should see the slides.
That's better. Yeah, that looks like the one. Well done.
Okay. So when James reached out, we talked about institutional support. I'm going to be talking about the institutional support on the side of a publisher, an association publisher. So I'm the data editor for the American Economic Association. And of course, my background here is not the natural sciences, the social sciences. That doesn't mean there are challenges, and these are challenges we may have addressed. I'll get to those in a moment. So the American Economic Association is the largest association of economists in the world, but what is key here is that we also publish 8 journals. One of those is considered to be one of the top, and the others are pretty good field journals. But my whole focus in being the data editor here is not to just speak for our own specific journals, because it does not make a lot of sense to start to improve certain things about reproducibility or archiving or curation of topics if you're at the very tail end. We've just heard from all of my colleagues who've spoken about infrastructure at the start of the research cycle. It doesn't make sense to make anything specific at the end. So there's a lot of coordination among a group of us at some other econ journals, and there's a focus on reaching out to the entire network of economists. At our journals and our association, data and I now call them data and code availability policies have been key since relatively early on. The first data availability policy goes back to 2004. When we launched all those field journals in 2009, they had data availability policies as compulsory provision of supplementary materials right from the start. But the recognition that just saying, drop us your stuff and somehow this will work out fine, didn't quite work out. And so in 2017, they made a search for a data editor, appointed me in January of 2018, and here we are today. One of the things is, of course, that we don't start from a void here. We actually have quite a number of deposits. So one of the things that I did as data editor is migrate those random zip files lying around journal websites to a proper curated data archive. The graphic shows the inflow of those replication packages over the years, in particular since those journals were done. So on around 300 packages a year. But there were exemptions that led to some code not being available, some data not being made available, etc. So those are things that we've worked on. So challenges, issues generically, in the articles that we see coming in, and I'm at the very tail end of the process. We don't do this at ingest, we do the vetting that I'll go to describe in a moment at the tail end of the editorial process. So once an article is conditionally accepted, I get to see the article, I get to see the associated code and data being sent to me, or me being pointed at them. One key thing is that there's nearly 100% lack of data citations. There is poor data metadata. 80% of the code has some sort of bug. It's not necessarily a huge amount of bug, but there are always things that break, that prevent us from running through right from beginning to the end. And I'll get back to that in a moment, because that's really important for us anyway. There is really poor description of data provenance. It's still much like, yeah, I have this data and it's wonderful, believe me, which of course is not sufficient. A more structural problem is the use of restricted data that cannot be copied, deposited, etc. But of course, the 60% that does have data that can be deposited doesn't necessarily mean that they should deposit it, nor that they should hide where it came from. The scale of the packages that we have are typically in the less than 2 gigabytes code and data together range, but the tail of that distribution gets to be pretty large. About 1% are larger than 20 gigabytes, and the largest packages that we've worked with are in the 200 gigabyte, 50,000 data file kind of scenario. Now, there are advantages to doing this in economics, in the social sciences. First of all, we don't have a lot of software diversity. So almost all the statistical analysis is done in, as it turns out, commercial software, Stata and MATLAB. And that kind of helps to some extent because there is a common language in terms of how the software is supposed to run. Stata also has excellent backward compatibility. There's very little that doesn't work from, say, 10 years ago in Stata. Quite astonishing, actually. Economists and social scientists in general don't do a huge amount of collection on average themselves. So I guess 80% are secondary data use. That has the advantage that there's a commonality about what people think about the data, what they know about the data, etc. And most of the code problems are actually easy to fix. That's, of course, hassle, because if it was so easy to fix, why didn't people fix it in the first place? But it also means that we can circumvent some of the data description problems that my colleagues have mentioned earlier, that they're very focused on getting a lot of information about how the data is structured, how the data is described, etc., because our code kind of does that for us. If it works and there's lots of people who are reusing these secondary data, then the code is kind of an implicit data documentation. And there is broad support for reproducibility. Those packages in 2004 that we started to collect, well, they weren't actually the first ones. The first replication packages that we actually found on our websites go back to 1999. So data availability policies were more of a response to a request to manage this than it was to force people to do so. So what have we done in terms of institutional enhancements at the association? I already mentioned we went to a proper curated archive. We migrated about 3,000 replication packages, burst open those opaque zip files. That does burst open a lot of problems as well, but that's down the road. We worked with the repository to streamline the deposit process. That's still not where it should be, both from a user perspective and from a journal perspective. It certainly could be better. We worked with them to enhance the metadata schema that was applied to our domain-specific repository using what most economists use, the JEL classification, to get better findability. But we also went back and did an experiment with authors of those legacy packages to ask them to add additional information to the existing schema, the generic Dublin core schema that's present on social science repositories. The biggest lift was essentially that we've implemented a pre-acceptance reproducibility check. So we actually check the computational reproducibility of every replication package. We check the data provenance. Is it intelligible? Is it well written? Does it make sense? Does it exist? That translates to, on average right now, the first full year, we had around 500 manuscripts. Because we see most of them a second time, because of all those things I've mentioned earlier, we've had around 800, 900 requests for verification of the packages associated with it. I mentioned restricted access, and one of the early comments I usually got in this position was, yeah, you're just gonna let those fly and then, you know, nobody checks them. Not actually true. We actually were successful in working with various third parties and going through the data access protocols when possible to actually check 27 packages that had that were done through third parties. We also signed about a dozen NDAs to get access to the data and then actually check the reproducibility of the code. Like I said, that really all doesn't make a lot of sense if we're the only ones who are going to be doing it, because we want the packages to be in a particular state. We want them to be described in a particular way to make life easier. And so we've worked amongst a smaller group of social science data editors, mostly economists, to come up with stronger guidance, to come up with a template README. The README encompasses both the instructions on how to run the package, how to generate the results that are in the article, but also the data provenance for many journals. And so to actually implement changes at an institutional level, we've had to become very hands-on in ways that I didn't actually imagine when I took up the position. We've had to train folks on how to actually cite data. It's a key component of the FAIR principles that you identify where data comes from and assign attribution to whoever came up with the data in the first place. Often that attribution is institutional, and that is notoriously ill-cited in economics. Data provenance, lots of folks don't actually remember how they got the data, and so we're going to have to read those, verify for correctness, we're going to test the URLs, we're going to go through some of these processes as well to help others find and access those same data sources, even when those data sources might be restricted or unique. We've had to provide strong guidance of what it actually means to prepare archives. We're actually willing to accept archives that are deposited in any trusted repository, but most of the time they will go through our own. And so we've done some guidance there. We've reached out and tried to get people to improve on things such as simple fixes to their programs that would just make everything a lot easier. The most common issues there, and that's kind of where the focus is this year. But we've also had to work on making access to restricted access data easier, if not just for the purpose of reproducibility checking, but also in the purpose of making it easier for folks to use it in general. We've talked to every one of these and more folks to try and come up with common notions of how to better share data, of how to render restricted access data more accessible, how to verify reproducibility when that is problematic. This has to go through education, and that's where the whole percolating back to the source kind of thing goes in. Of course, we're going to have to train the researchers in some of these methods, but the next researchers are our students, the graduate students, the undergraduate students. And so implementing in education a culture of replication and the techniques and mechanisms of doing that is one of the key things where we are working on providing some of that. This may come as to a surprise to some of my colleagues here. It is extraordinarily surprising that we have not, in all those 500 packages that we've seen, found a single Docker image. And yet some of those methods, I'm not going to harp on Docker specifically, are cutting edge and should be there. So that kind of improving the code, improving the infrastructure, where to host the data, where to host the computation, etc., interacting with places that have that needs to be common to all the journals. So there are first signs of improvements. We are seeing that this is starting to have an impact. The next 500 manuscripts will show us where that ends up being. So feel free to contact me and look forward to the discussion.
Brilliant. Thank you very much, Lars. Nice to end on a slightly positive note there. Obviously, there's a lot of work to be done to get people to really think through how this that's going to work. We've had 5 very diverse questions. I know we've got some questions in the Q&A. I'm going to let Keith take over at that point and be the go through the Q&A. We have a chance after that. It might be good to talk about, try and bring some of these things together so they look like from the institutional perspective, and to maybe introduce 1 or 2 things at the end about what we want to discuss next time. For the time being, Keith, do you want to take us through some of those questions?
Well, actually, I've just discovered a very interesting feature of this this software, and that is if you accidentally leave the presentation, which I did, the Q&A disappears. So
okay,
James,
right.
James, I hope that the Q&A is still working for you. So
Thankfully, yeah, I haven't left the presentation at any point, so I can still see all the questions and how many votes they've got and everything else. So let's rattle through the questions. I don't know how to sort them or arrange them, but I'll have a look through. So there were a couple that were answered during the talks, but I think it might be good for everyone if we can hear them. So there's a couple from Magdalena. Is there an exchange and/or networking with the LN software providers to enhance the usability, integrate feedback from researchers, or better support, for instance, FAIR principles? And actually, if I can tag on to that one, something about the metadata, Magdalena, that you're getting and how that can support it, that would be quite interesting, I think. You may be muted, Magdalena, either that or people may have fallen out. Okay, maybe we'll come back to that one. Question about Heterogeneity, again for Magdalena. So as the area is very heterogeneous, as far as I know, there is no central network. Open source tools such as eLab, FTW are easy to expand in the community here. Oh, sorry, that is the answer from Magdalena. I will get the hang of this at some point. Right, so have a look in the Q&A section if you want to see Magdalena's answer for that one. And there's another one as well here that's already been answered by Magdalena. Magdalena, you're with us. Do you want to say something a little bit more about those two questions that you've already answered?
So yes, I answered the one question. There's, as far as I know, no centralized group where all ideas come together. The tools that are open source, for example, eLab, FTW, have a very strong community, and there's like every week a new update for the software, and it is easily to just push some needs, and they will be integrated. But there are also some proprietary tools where you can pay for the needs to be integrated. Yes, and the other question, I had to leave, so I don't see it. Maybe you can just repeat the other question.
Oh, okay. Yes. How do you integrate the ELN into the open parentheses meta close parentheses data repository?
So yes, this is one of the questions we are working on in our Eln working group, because as far as I know, this is very tricky. But I would like to refer to the talk of Holger from the Skibo RDS. This might be a tool where you, on the one hand, have, for example, the Eln on, and then the Skibo RDS, and on the other hand, the repository, and the data can flow this way. But yes, in my point of view, this still has to be developed, and it's at the beginning. I hope.
So maybe actually this is a good moment to bring Holger into it. So Holger, I was interested in that one of your kind of activities that takes place on data when it's pulled through is to apply some kind of metadata to it as part of your Skibo RDS. Could you maybe say a little bit more about that and the kind of what metadata you can apply to the data?
In fact, as far as I know, it is configurable by the administrators what scheme exactly you are asking for here. So it's not hard-coded by us what metadata we will storing.
Okay, and I noticed that there are some other questions for you here as well. So in your system, is there a version control system integrated?
No, it's not. But the reason is that this is also already a part of OwnCloud/Nextcloud. And so we are not in need of a version control system. And we are, as Skibo RDS, not storing any data. We are just using the data from OwnCloud. So there was the right place to do the version controlling. And by the way, I tried already to answer all questions in the Google Documents doc.
Okay. Yes, that's good. We'll rattle through anything else that jumps out at me here, just to so that everyone can hear a kind of spoken answer. I think, because otherwise we've already got about 5 different channels now for answering questions. But we'll see. We'll stick to the original plan to some degree. Do you plan to also create a connection to DuraSpace products, e.g., DSpace, DSpace Chris, which you use frequently as institutional repositories?
To be honest, I don't know DSpace or DuraSpace, but I can give at least a general answer here. Currently not, but there are 2 possibilities. You can do this by yourself because our code is open source and you can collaborate with us on this. Or if you could try to convince us to do this by also, talking to us, and if you want to use our product and this is the one feature you are missing, then maybe we can put this on our agenda. But currently it is not.
Okay, and I've noticed a couple of other relatively technical questions that probably are perfectly be answerable in the Google Docs. So is the metadata able to accompany its object during the whole life cycle of the object file data artifact?
Yeah, I would say yes, it is, because the data should be in our system during their whole life cycle. You put your data in there, then enrich them with the metadata, and even if you push them to some services, they still remain in the sync and share service unless you delete them there. And the metadata you need for pushing them to those services will be taken from this OR crate in the central service, but stays there. So therefore, I would say yes.
Okay. So opening this up to the floor now, you should all be able to turn your microphones on, I believe. So if anyone does have any questions for any of our 5 speakers that you would like to put forward in speaking rather than in writing, please do so now. I actually have a general one, which will involve all 5 of our speakers, hopefully, and that's that obviously we've heard quite a diverse set of different talks here about quite different topics and quite different subjects. But what I'm interested in is how they all apply at the institutional level. So I work in a fairly generalist university. With what you've been talking about, what is the lesson that I need to learn? What should I be doing to make researchers' lives easier and better? How can I use your innovations? How can I use what you're doing to make the world a better place? And I don't know if all 5 of our speakers can have a think about, what's the next steps for the institution? How does the institution help you with what it is you're doing? What can we do? And maybe if I can start with Daniel, if Daniel's around, and just say, how can the institution support you? I think you might be on mute, Daniel.
Yes, I was muted. Sorry. First of all, I want to connect my talk to this tool from Holger. Holger, more or less, let the data be in the Nextcloud or own cloud. And especially there, I see a problem, and therefore we developed our tool instead of Nextcloud, because metadata is not versioned in Nextcloud, as far as I know. The data itself can be versioned in Nextcloud, but easily overwritten. If you put the same file with or another file with the same name, the version control is destroyed. Therefore, I see here really a problem to have some useful stuff. And when we are finished, we can at least describe how we can use open source tools like JIT or other tools to build such a platform in-house to use it and give more or less the output, the metadata to Holger, and then go on to the publication.
Okay, Holger, do you want to respond to that briefly?
Yes, it's a valid point you mentioned there that the metadata might be overwritten, maybe by users' interaction. As far as I know, those version control is more or less reliable, but you are completely right, it is not completely reliable. So if you do enough modification of your data, they actually will get lost. So therefore, you might run into problems if they are changed frequently. But on the good side, I think those won't be the case very often. So the crates we are creating here are stored as a hidden file, so a user shouldn't see those files and try to edit them by hand or overwrite them and not accidentally create a file with the same name, so that this hopefully does not become a huge problem for us.
Good luck.
Okay. Okay, let's bring back Andrew then, if you're there, Andrew. So talking about GraphQL and Relay, what could an institution do? What could the institution be done at the institutional level to kind of support some of the insights from research that could come from that? What should we be looking to do?
I was actually thinking of the shape of data, which connects, I think, with Lars and the problems and issues that you've been addressing, certainly within my own institution, but also with the wider conservation and preservation communities. There's a lot of repeating and cycling around and around and around, and people coming up with new ways to describe the same shit. It drives me nuts. And especially when they become more and more convoluted. The ELN systems as well. This is again to do with the shape of data and being able to exchange it with others and reproduce results. I mean, that's the headache I face on a daily basis. That's also what kind of pushed me towards GraphQL in the first place, was that here I can create at least some order amongst the chaos. Yeah, but I don't know, it's just a recurring issue in my world, at least.
Well,
if I can... Sorry, carry on.
I was going to chime in and say that I've been part of groups at the university to talk about support for data policies in general, and how those can be made aware. And there's always going to be disciplinary differences. So, say, Magdalena's notebooks are not going to be used and don't warrant training for social scientists. Maybe they should, but they aren't probably. But there are some general guidelines that some universities obligate their researchers to take on a regular basis, having to do with the ethics of research in general and some general principles. And just being aware of what is done in neighboring disciplines can often be enlightening. As I mentioned, I think, say, social scientists would warrant looking at what computer scientists do. If you're writing code, then you should write code the right way, not the wrong way. And there are certainly lessons to be learned there, and vice versa. There certainly is scope to do that, and that's why, to some extent, we've, together with my colleagues at some of the other journals, we've sort of migrated towards trying to get this into the educational stream of the students, to not just have it be an optional workshop that interested parties can take, but to actually have some of the basic principles be part of the general curriculum for undergraduates and graduate students. And I think that's where institutional support is critical.
Elaine, maybe if I can turn to you, I should declare an interest in that I'm actually currently trying to implement an institutional ELN system at the moment, so listening with some attention. And one of the things that struck me about yours, and actually which Lars just brought up, is the interdisciplinarity of, or otherwise, of ELN systems. To what extent do you think that ELNs will always just remain something that's essentially for wet lab disciplines, life sciences, those kind of things, or to what extent do you think it could be applied more broadly?
Good question. First of all, I think ELN are a very good way to push researchers into the direction of RDM, to know what RDM is, because with ELNs you can make their life easier. I'm a biologist, and I was writing every day 1 hour in my lab notebook, and if I had an ELN, I think it would be more efficient, and I could just share very quickly my research results and so on. And I think it's very essential to make this clear to the researcher, so that they see this is not something they have to do on top, but it's something to save time and to be more efficient and have more time for the fun part of lab work. And yes, for the interdisciplinary aspect or the broader range, I don't know. I think ELNs are very, very natural science specific, but in the end, every researcher has to document. So maybe there should be a way to, open these tools and make it even more.
Maybe this is an area which perhaps we should focus on a little bit more, trying to bring the kind of disciplinary expectations and tools that people are using and learn from each other, which does bring me neatly towards the end of this session, because we tend to, in the Ardari interest group, we tend to sort of move from subject to subject and try and explore in as much depth as we can in the time available how institutions can help benefit and produce a better kind of infrastructure or research environment, better architected services for various issues. And it'd be good to get, if people have any suggestions now for things that maybe we might want to cover as a group at the next of these meetings, that would be good. So I don't know if maybe there's an interest in learning from different disciplines and the different infrastructures and architectures and services that are used, and see if we can learn that, or if there are any other burning issues that anyone wants to raise, which they think might benefit from the Ardari treatment. Silence. Well, what we shall do is we will arrange meetings between any interested groups. If anyone wants to join the Ardari interest group and join us for one of our meetings between the plenary sessions, we will put our heads together and try and come up with some good suggestions for future panels and so forth. The other thing that I should mention before we go, Keith mentioned something.
Sorry, James. Yes. So first of all, thank you all. Please add any ideas and perspectives into the collaborative notes document. There is also a link there to join the interest group. If you are not already a member, please join the interest group, and you will be alerted to our next virtual meeting. And there we can discuss future topics that we want to address. So please take that up. That would be great. We welcome new members to the interest group. What we also welcome, and I think that's where James was heading, was the fact that we could do with another co-chair, because currently we have a very limited group, which is also not very diverse in its geographical spread or its gender and all the other things that we're facing. So we would welcome more diversity and more co-chairs for this working group, interest group. So if you're interested in joining, please approach us, join the group. Have a chat. We'd be very welcome to having a new co-chair to join us.
Yes, I don't think we're diverse in any way whatsoever. So do please come join us and help shape future sessions like this. I think our time is basically up. So thank you very much for 5 very interesting perspectives on, different but related issues. I think hopefully we've all got something out of this session. Hopefully, if nothing else, at least we've figured out how some of the technical issues work and can be overcome. And I bid you all a very happy 17th plenary RDA. I hope everyone has a great conference here, and hopefully I'll catch up with some of you guys before too long as well. So thanks to all of you who've joined us this morning, and enjoy your lunch.